Hey everybody and welcome back to Jim's Garage. In this video I want to share with you a project I found that makes spinning up local LLMs a cinch, and the beauty of it is everything's containerized within Podman and has a wrapper of Toolbox around it to make administration simple. Now, I featured this in my MSS1 review so that anyone who's on a Strix Halo device or any other device with unified memory should be able to take advantage of this approach. Now, I'm going to let the person who created this introduce it because they'll do a far better job than me. But at the end of this video, you should have this environment spun up and you should be able to run all of your LLMs locally and take advantage of obviously all the privacy and all the learning and experience that comes with that. Over to you, Donato.
Hi everyone, my name is Donato. I work in cybersecurity research and consulting, and I'm mainly focusing on securing GenAI systems against things like prompt injection. But on the side, I've been running a YouTube channel where I mostly experiment with building LLMs from scratch, and honestly, it's been my way to push myself to learn and have a little bit of fun. Now, my interest in local inference really started when NVIDIA announced the DGX Spark that actually was supposed to land Q1 2025. And I was planning to get one to experiment with local inference, but NVIDIA really delayed the launch. So I started looking elsewhere. And that's when AMD's Strix Halo came into the picture for me. I really liked the unified memory that was available to the integrated GPU and the fact that it was actually available in July when I needed it. So I picked up the HP Z2 Mini, and later Framework also sent me their desktop for testing. So this became my hobby side project, and I started looking into how to make things work and optimize performance on these honestly relatively new and unsupported hardware. But this also gave me the chance to get in touch with AMD developers, llama.cpp developers, and others in the community, like Leonard, known as LHL, who taught me a lot about what I know now on inference and AMD GPUs. For example, along the way, I discovered that llama.cpp can be built with multiple backends to leverage AMD GPUs. You've got Vulkan and RawChem, and each of these can be further configured, and there are different versions. So I started benchmarking everything. Different model architectures, different quantizations, different backend configurations, all compared side by side, and I maintain a public page where all of these benchmarks are available for review. I also automated the process of building llama.cpp containers for every backend. So every time there's a new version of llama.cpp or a new version of RawChem, these get built automatically. These ways you can always pull the latest container with the newest tools and patches, and these are all tuned for performance and stability. Now, throughout that process, I found that right now, RawChem with ROC WMMA performs really well because the WMMA extensions basically allow llama.cpp to access optimized matrix multiplication pathways in the GPU. Vulkan is also a good alternative right now, and it still wins in a lot of cases depending on the model and the quantization. And I can tell you that there's active development right now on llama.cpp to write custom GPU kernels for AMD GPUs. So in a few months, we should see performance improve even more. Finally, my goal with this project is simple. Make Strix Halo systems like the Framework Desktop or the MSS1 Max into proper local AI servers, not just for text, but also for image, video, and voice. And by the end of October, I also release the first container to easily train LLMs on Strix Halo together with a tutorial. So stay tuned if you are interested in this kind of stuff.
Thanks for that, Donato. So let's get on to the deployment. Now, thankfully, Donato has a GitHub page with all of his code available, so I recommend that you go and have a read through this first before you get into this tutorial. What's great about this is it's regularly updated, and also he has a link to one of his benchmark websites here, which if we click on this, you can see the interactive benchmark viewer here, which shows all of his results that he's had on these devices using various different models. This will become more useful as you get stuck into this. Now there's a ton of ways in which we can deploy this. Donato uses this on Fedora. I'm going to be doing this on Ubuntu 24.04.3 LTS version. So basically choose whichever version or whichever distro you want to do, but that's the one that I'm going to be using for this tutorial. Now, no doubt within a few weeks this is probably going to be out of date. There'll be new versions of Rockham that come out. There'll also be new distributions of Linux, etc. But for now, this should work, and at least it should give you a flavor of what the process looks like. Thankfully, it's not too difficult, and we're going to be following most of the instructions on here. I have tweaked it slightly for my Ubuntu installation, but broadly speaking, all of the hard work has been done on this page. So all of the commands that I'm going to be using in this video will be available on my GitHub, but as I said, make sure you check out Donato's GitHub page because this will stay up to date. So I'm going to go away now and install Ubuntu, and I'll see you on the other side when we've SSH'd into it for the first time. Now that the installation is complete and I've SSH'd into that machine, we're ready to begin the deployment process, but there's a few prerequisites first. So let's make sure first of all that we update the system and pull down any upgrades. With that done, we're ready to begin the actual installation process. So we're going to head over first and make sure that we've got all of the drivers installed. That will include the Rockham drivers and also to make sure that we've got the latest Radeon drivers for this Strix Halo machine. To begin with, we're going to head over to the AMD official website and we're going to install the Rockham software. Now this comes in kind of two requirements. We install Rockham itself, but we also make sure that we've got the latest AMD GPU drivers for the Radeon, the 8060S that's on this Strix Halo machine. Once we've done that, there are a few important post-installation instructions. We need to configure the Rockham shared objects, the path as well for the system. There's a few options there. And also if we scroll down, we need to change this path here and configure the library. Now, that's all straightforward. I'll have all of that on my GitHub. So we'll just work through this now and make sure we understand what's going on. Now, as well, this is just the quick start. I'm not going through the detailed installation options. If you wanted to, you can click over here on the different installation methods if you want to go through and learn about every single thing that's customizable in this. This will change definitely in the near future. There's going to be new distros for Linux coming out. There's going to be some huge updates as well coming for both Rockham and how it interacts with the kernel, etc. So this is very much an as is for now. And as it's a test thing that I'm spinning up, I'm not too bothered about just getting it spun up with a quick start guide. So back over on this machine, let's just clear the console, and then we're going to get started on the actual installation itself. The first thing we're going to do is to download that Rockham. So we're going to pull down the Debian file, we're going to install it. We'll also then pull down some dependencies. We're going to modify so that the user is added to the render and the video groups, and then we'll go ahead and do the actual installation of Rockham itself. Now, this might take a little while. You'll see in a minute it's got to pull down quite a lot of additional repositories. We'll hit yes on that one. And then we need an additional 23 gigs here for all of kind of the make files, etc. So I'm going to skip ahead, let this install, and I'll see you in a moment once that's completed. If you do get some errors here, just make sure that you're on 2404 because that's what these instructions are for. If you're using a different distribution, head on back over to the AMD website and choose the instructions for your distribution. Now that that's completed, we're going to run the following command, which will pull down the additional Linux headers we need and also the extra modules that are required, and then it will go ahead and actually do the installation of the drivers for the graphics. So hitting return, that will go away. It's going to pull down an extra 600 megs, and I'll see you once this is completed. Shouldn't take as long as the last one. One thing to note is I have disabled, as you can see here, secure boot. If you do have secure boot on, you will need to set a password, and then the next time the machine boots, you'll have to put in that same password. I'm not putting it on just to make life simpler. I've had some issues in the past with secure boot and using different Linux distros. As this is just a test device, I'm not too bothered about having that enabled. Now that that's completing the installation process, the next thing we need to do is to do a reboot just to make sure that all those settings are applied. So let's do a reboot, and I'll see you when this thing is loaded up again. Now that we've rebooted, we need to paste the following, which will set the Rockham shared objects. So with that done, we should be able to move on to the next step. Firstly, we can display all of the ROCm devices with this one here. You can see that we've got 7.0.2, and then we need to update where the actual library file is. So hitting return, now that we've done that, we can verify the installation. So we can do that twofold. So firstly, we can check the actual ROCm packages are installed. So this will show everything that's on this machine. If we scroll up, we should start to see, all of the ROCm stuff here, which is great. We know that that's now installed. The next thing we want to do is to basically check which version we've got, i.e. check that the hardware has been picked up. So to do that, we can run the following command. This will spit out anything that basically is penned to it. So here you can see I've got my 395 with that 8060S, and it's the AMD Radeon graphics, which is what we expect. Now that's pretty much all we need to do to get the ROCm up and running. But there's definitely some additional tweaks that we need to do to make sure that this runs optimally. And it's crucially around modifying the grub so that we get all of the system RAM for the GPU to use, and then a few other tweaks as well regarding the IO MMU. So we're going to head now into the grub file and we'll put the following additions in there. Obviously, if you've got more than 128 gigs of RAM, you can scale this up to suit whatever you have, so maybe 256 for example. So if we head into the grub file itself, we want to go down to this default line here, and we want to paste in the following values. So here we're saying that we want the AMD IO MMU off. I believe that improves the latency of the memory. We're then setting the page limits and the GPU size. So what we need to do there is save that, and then we'll exit it. And then we need to update the grub itself. So sudo update -grub. That should go away and do that, and then we will also need to then do a reboot to make sure that those changes apply. Once the machine has rebooted, we'll be running a couple of commands just to make sure that those changes have taken effect. Essentially what we're doing here is telling the Linux installation that override the default amount of VRAM assigned. Because it's using unified memory, we're saying that the GPU can access basically all of that unified memory, and in an ideal case we want as little memory as possible assigned to the running of the operating system and all of it assigned to the GPU. You may get some stability issues if you choose that number too high, but from all of my testing and the best model I can run on here, the Qwen 3 120B, that runs at around 90 to 100 gigabytes, so we've definitely got some additional headroom there, so I haven't encountered any issues. Now the machine's rebooted, we can run the following command, which will actually go and then query the GPU to find out how much memory it's got. And with any luck, we should see that we've now got 131 gigs of the memory that the GPU can use, which is awesome. That's exactly the result we want, and we need this in here because we can't manually assign that otherwise. Now we effectively have everything in place to be able to start running these models. So the first thing that we want to do is to go and install the Podman Toolbox, which isn't part of the Ubuntu installation. If you've got Fedora, it should be installed by default. So that's going to go away and pull that now. It should be pretty quick. And the next thing we need to do is pull down Donato's Toolbox. So effectively all we're going to do is clone that repo, which is as simple as the git clone command. Once that's done, we should have the toolboxes here within this folder, and we're ready to start doing some actual testing. So if we change directory and hop into the toolboxes here, you should be able to see that there are a number of different ones here. Now, Donato's Toolbox supports both ROCm and the Vulkan. Now, I'm just going to show the ROCm one for this video just because I've found that one to be the best for my use case. But basically, you can repeat this process for any of the toolboxes that are included here. So if you don't want to use the ROCm 7, or you wanted to use ROCm 6.4, or you just wanted to use the Vulkan, you just need to change the command that we're going to use to reference these different toolboxes. It's that simple. Once you're inside this toolbox, everything else is the same. It will behave just the same as you would expect. Now we need to actually create the toolbox itself, and that's as simple as creating this toolbox here. We're specifying a Docker image, we're specifying the device we want to pass through to it, we're adding the group so we can use it, and we're adding the sudo group. Now, I am running this as sudo, which obviously from a security perspective isn't great. You could add this user to the group so that you don't need to run this as sudo. There's instructions on the website of how to do that, but essentially it's this. We can see on Donato's GitHub that we need to create a new rule here, and we then need to add in the different rules that will allow the permissions to go through to that user, so we don't have to run it as sudo. But I'm just running it as sudo just because I haven't found any issues with that, and I couldn't always get this rule to work reliably. When we run this command, it's going to go away and create the toolbox for us. It's going to say that it doesn't have that image locally, so it's just like any kind of Docker installation, or Podman in this case, it's going to go and retrieve that image first. So once that's completed, we should be on to the next step, and handily it will tell you how to enter this container itself as well. We'll use the toolbox enter and we'll be able to dive in and start using it as normal. Obviously the benefit of this approach is all of the dependencies, everything that's required to run these LLMs is inside a container, so it's not polluting the operating system itself. And if you wanted to start fresh, you simply just delete this container and there's no fallout on the operating system. We're not actually modifying the operating system outside of just installing the drivers and the ROCm itself. So this is why I think this is a great way to be spinning up and testing LLMs and have an operating system that will stay clean. So now that's completed, you can see that we can enter the toolbox here. So again, I'm just going to use the sudo to enter that. The reason I'm doing that is because I didn't add that rule. I could go back and add that rule, but also because if you don't put the sudo in, it's not going to have access to the GPU itself. So hitting return there, you can see that we're inside this toolbox now. And a good way to check that everything is working is to run the following command, which will list the devices that this toolbox has access to. So if you run the llama CLI and list devices, we should see here that, yeah, we've got that ROCm 0 AMD graphics. So as long as you've got a GPU specified here, you're good to go for the next step. If you don't, go back and check that you've followed the previous steps okay, and that you've got the GPU, the drivers, and all the permissions correct. Now that we're actually inside this toolbox itself, we're ready to run the following command. Now, this is going to pull down pretty much the best and largest model that I've found, and that's kind of what Donato's Toolbox, where he's got his live performance benchmarking site, shows. And also there's a few options here that we need to go through. Now, looking through these options, anyone who's familiar with running Llama locally, this is exactly the same thing, it's just Llama within a container. So importantly, we want the no memory mapping. So what that will do is force this model to run just in the memory. And that's why we specified earlier that basically use all of that memory, because it'll enable this model, this is quite a large model, nearly 100 gigs, to fit just in the RAM. So we get all the benefits of speed. Next is the number of GPU layers that we want to be able to add into the memory. And then we've got the flash attention, which I've set to on. And that, as far as I'm aware, is a way to optimize the model and how it runs within the memory. Next, we've bound this to the host interface. So the benefit of doing this is you should be able to access this from other services, other machines on your network. Effectively, like we've done many times in Docker, you should be able to go to the IP address and port 8080 and be able to access the web user interface that I demonstrated during the opening of this video. So the good news is this does ship Llama server. It does have a whole graphical user interface. Next, we have the -hf, which is Hugging Face, which for anyone who knows is basically a repository for storing LLMs. Now you can do -m here and specify a model that you've downloaded manually, or you can specify the -hf and then reference a model on their website, and that'll go away and download it on the fly. The model in question over on the Hugging Face here, you can see on this right hand side down here, we're using that Q3KXL, which weighs in at around 104 gigabytes. So that's why this is pretty much the biggest model I've been able to find that will run just in memory, and it's pretty much considered one of the best quantized models that's out there at the moment. Obviously, with everything that's happening in AI, this is probably going to be out of date by the time I publish it, but come over to their website, have a look at the reviews, look at the performance graphs, check the size, make sure you can run it in the memory, and then choose whichever model is best for your use case. If you want to be using this for coding, for etc., for example, then go ahead and download one that's specifically been optimized around coding. Now, to run this model, we want to just hit return. That'll basically go away now and download that model. This is going to take a long time because it's nearly 100 gigs. So go make a cup of tea and come back when it's ready. And once it's ready, we should be able to open up the web browser. We should be able to access this and also get some performance metrics. Now that the download's finally finished, you can see down here that if you're running this in VS Code, it'll have already set up a port forward. So you can click here to open it in the browser. That'll take you now to that GUI that I showed you earlier. But also, because we bound it to the host on all the interfaces, you should be able to go to the IP of that machine and put in port 8080, which is the default for the Llama server browser. So for example, if we come out of here, we should be able to go to the IP address and 8080. So in this instance, it will be that 8.75.8080, and here you go, we've got that same user interface. So now basically everything on your LAN or whatever you want, you could port forward to this, etc. All of your machines should have access to this, mobile devices, etc. And so the next step really is to replicate this process. You can spin up additional containers. You could use different accelerations. So you could use Vulkan instead of Rockham. You could also spin up different models. And basically this gives you a repeatable and quick way to spin up LLMs and do all of your testing. In a future video, I will be using this local LLM to actually plug in and use for different services. So things like NA10, we can run this using a local LLM, or something like VS Code itself. Instead of using the Copilot it's bundled with, we could actually use our own local LLM. That would be great for privacy, probably not as good as the big open models or the ones that you have to pay for. But at the same time, if you're into it as well, you could also train it specifically for the work case that you have in mind. Anyway, I want to thank Donato for an awesome job in creating this toolbox. I think it's the best way I've found to quickly and rapidly deploy and test all of these LLMs. So let me know what you think about this in the comments below, and if there's other alternatives that you have used. If you are going to be using this, let me know what you've got planned for it and how you're going to integrate it into your home lab. Anyway, as always, if you've liked this video, please give it a thumbs up, hit that subscribe. I'll see you on the next one. Take care, everybody.